We were talking about square root functions, and we talked about the parent function, which is f of x equals the square root of x, correct? Yes. And then we said that underneath the square root, what value can you not have? A negative. A negative. So in order to not have a negative, my value has to be greater than or equal to 0. Do you remember that from yesterday? Everyone good with that? Okay, so we're going to dive into another example of doing this. And then I'm going to get you one.
You want me to take the other light out?
Yeah, I mean, I don't mind. Still hard. Does that bother anyone? Both lights out? I contemplated getting another lamp, but I don't know if it will make a difference. All right. So now, take the screen. You see nothing. I thought it erased it. It did not. All right. So what I would like you to try, using your notes from yesterday and a neighbor. Huh? You should have space. Y'all don't have space? You know what to do that. Thank you. You're going to do g of x equals the square root of x minus 10. So you're doing g of x equals the square root of x minus 10, and you're finding its domain. Remember, first step is to set it up. Second step is to solve for x. So set it up, solve for x. Set it up, solve for x. So step one is I take whatever is underneath the square root, and I make it greater than or equal to 0. So I have x minus 10 is greater than or equal to 0. Step 2 is I'm going to solve for x. So my security is a negative 10. I'm going to knock it out. I'm going to add 10. So what I do to one side, I do to the other, and I get x is greater than or equal to 10. That is my inequality answer, right? If I wanted to dress up my inequality and turn it into a set builder, I would add my braces x such that and close it, and that's my set builder, right? That's the fancy way of writing it. So if it asks for set builder notation, it just means I add those 4 things to my inequality. Open and close brace, my defined variable, my such that. Okay? Then the other way to write it is your interval notation. Your interval notation is saying, what does this mean? This is saying that I am starting at 10 and going forever to the right. And so what is forever to the right called? Positive infinity. So I start at 10 and I go all the way to infinity. Because it's equal to, I'm going to use a bracket. And because infinity can't be included, I use a parenthesis. Those are the 3 ways you can write your answer. Which way you write depends on what the problem is asking of you. Got it?
So anytime there's a negative in the front or the back, you use the parentheses.
Anytime there's infinity, yeah. If there's negative infinity on the left, you're going to use a parenthesis. If there's positive infinity on the right, you're going to use a parenthesis.
So it's going to always be a bracket or
For infinity, it's always parentheses, no matter what. Because you can't include infinity because it doesn't have a defined stopping point. It goes forever.
So it's always going to be a bracket and...
For this root, yeah. For a square root, it's going to be a bracket and a parenthesis. Or it could be a parenthesis and a bracket.
Okay.
All right? So h of x. I'm going to let you try that one. I'm going to give you h of x. And h of x is the square root of 12 minus 2x. Remember, first step is to set it up and make it greater than or equal to 0. Step 2 is to solve for your x. Ready? Good. On this one, my inside is 12 minus 2x. And I'm going to set it up as greater than or equal to 0. I need to isolate my x. So remember, think about your x as the vault at a bank that you're robbing. Okay? Your first line of defense is the defense that's away from the vault, right? That's your security. So how I'm going to knock out my 12 security guards? I'm going to subtract them. I'm going to minus 12. So this gives me one step closer to the vault. And now I'm close to the vault. How am I going to get through the vault?
Divide by -2.
I'm going to divide by -2. When I divide by a negative, what happens to my inequality? It flips.
Oh, I did it right.
So I'm left with x is less than or equal to 6. So that is my inequality. If it asks for set builder, what would I do?
With the bracket, right?
I would just add the braces, my x, such that close braces, right?
And then it would be 6. Oh, in bracket 6, comma.
Would it be 6?
No, it would be the negative.
It would be what?
Oh, negative.
Negative infinity. Because it says for me to go to the left. So I'm going all the way to the left first. So negative infinity to positive 6.
So you tell that by the greater than?
Your inequality. Your inequality tells you which way you're starting with your infinity. How do we feel about square roots?
Good.
Good? Can we move on?
Maybe.
Okay? If you shake your head no, I'm going to ask you to wait till we get to the practice problem at the end. Or there's this place called tutorials you can come to.
Just keep it.
Okay?
Go.
All right.
You got it? You got it?
You told me to wait?
Couldn't see.
Oh.
Alan, you got it?
I had to figure out a new desk arrangement.
You know I got it. I don't know
To
yet.
like
I'm
fit.
telling you the square.
Thank you.
I've told
No, because I'm about to get 3 more desks in after school today. I need to mount it
Oh,
No, she had
to figure out how to reach the projector on the ceiling.
He's gonna take.
Tell me this don't look retarded.
I thought about starting a GoFundMe. Yeah, so that I could get someone to help pay to get my projector mounted.
That's real. Have you talked to Dr. Love about it?
They said it's too expensive. I don't know why it would be expensive, but
Every other teacher got it.
only the science wing has it.
Oh.
Only the science wing has it. I don't know. Yeah. All right, rational function. So rational function is when you have your variable in the denominator. So my rational function, parent function, is f of x equals 1 over x. And that's because my x is now in the denominator. Okay? So in the denominator, you cannot have 0. Why is that? In the denominator, you can't have 0. Why is that? Hit it out. It wouldn't be a real number. There's nothing, right? There's nothing you can divide 0 into, right? Does it make sense?
Yeah.
So a good way to remember, I literally have been using this in 6th grade. My teacher told us in 6th grade, it is okay for 0 to be in the numerator. But it is a no-go for 0 to be in the denominator. So if your 0 is in the numerator, good to go. It equals 0. Because if I have $0 and I'm going to share $0 with you, guess how much you're getting? $0, okay? See how that works? It's a no-go because we don't have anything to share. We don't have anything to start with. There's nothing that we're talking about. It's imaginary. It doesn't even exist. Okay? So, we have to solve the inequality. X does not equal 0. So in our previous restriction, we started off with x is greater than or equal to 0, right? And this restriction, it is x cannot equal 0. So it's the same 2 steps. You set it up, you solve for x. It's just that we are now setting it up to something different. Okay? Note that x cannot equal 0. This is also that is the domain of our rational function. So the domain of our rational function is x cannot equal 0. That's its interval, that's its inequality notation. For rational functions, right now, we're not going to stress set builder. We'll come back to it. But we are going to stress interval notation. So the interval notation here is, if you remember what a rational graph looks like, does anyone remember? What makes a rational graph really special? They start with an A.
Asymptote.
Asymptotes. A rational graph has asymptotes. And asymptotes are those imaginary lines that you cannot cross, right? So you have an asymptote on the x-axis, and you have an asymptote on the y-axis. So my graph cannot touch that. So as I travel along, I'm going to get as close as I can, but I never actually touch, right? And I have to stop, and I'm going to get as close as I can, but I never actually touch. And because of that, I actually have what's called a split domain. It went down, it's fine. We'll stop. So I have a split domain, which means that when I write it, I have to write it as a split domain. On page 5 in your interactive notebook, at the very bottom of our interval versus inequality notations, you saw that U, this is where that U comes into play. It's because I have a split domain happening. So I'm traveling along from negative infinity, and then I get to 0, and it's like, uh-oh, you can't pass. So I have to stop at 0, jump over, and then restart at 0 to make my way to infinity. And that is the interval notation for irrational. It has a split domain. So, if our x cannot equal 5, where 0 is, I would put a 5. If our x cannot equal 100, where 0 is, I would put a 100. It doesn't get any harder than that. It's just, we have a split domain, and that's where we're at. Ready for the example?
No.
I mean, you aren't going to understand more until you see it in full action. So you ready for the example?
Yeah.
All right. I heard some yeses and a woohoo back there. All right. So our example is 1 over x plus 5. So you're going to take whatever is in the denominator, not numerator, denominator, and set it not equal to 0. Take whatever's in the denominator and set it not equal to 0. Got it?
And then
That's step 1. Any questions about the setup? Easy enough?
Yeah.
All right. Step 2. Solve for x. If I have x plus 5 does not equal 0, I need to get x by itself. So what am I doing? Subtracting 5. What I do to one side, I do to the. So x does not equal negative 5. Was that any different, really, from doing a square root?
no.
No. So there's my inequality. And so then now I have negative infinity to negative 5 union negative 5 to positive infinity. And that's my interval notation. Those are your two answers. So depending on what you ask for, if it just asks what's your restriction, you can write this bad boy.
So this don't come with the brackets and stuff?
No. Well, when we actually dive deeper into rationals, we will go over the set builder for it. Because we have to learn some new symbols.
And how that one become negative? Is this always gonna be negative?
Infinity? Yeah, because what's to the left? Those are your negative numbers that go on forever, right? So therefore that's called negative infinity. And what's to the right? Those are your positive numbers that go on forever. Okay? Are you ready to try one? Ready to try one? Yes, Miss Jones, we are. Thank you for asking.
So nice.
Here you go. G of x. You have 1 over x minus 10. Find my domain, for favor. So step 1 is to do what?
Set it up.
Set it up. So I'm going to make it
X minus 10 equals not 0.
does not equal 0. All right, then what do I need to do?
Add 10 to both sides.
Perfect. And then what do I get? Perfect. So there's my restriction, and how do I write that as an interval? Perfect. My big old U.
No.
Backwards.
Perfect.
What if it's the other way around? We just still be wrong? No, I didn't do that. He said somebody.
Oh, yeah. You have to, because think about, yes. Huh?
I said not equivalent.
This is not equivalent?
No, it's if you write, if positive infinity,
That's what somebody back there
positive infinity, if you
Y'all not gonna make me
Yes,
like I'm
because you're
crazy.
splitting it in
Somebody
between.
said
Because that thing in the middle, you cannot touch 10. So I'm moving around 10. So I'm getting as closest to 10 on the left. I'm getting as close to 10 on the right, but I can never actually equal 10. Because that's the definition of an asymptote.
That's classic.
Is that I approach it, but I can't equal it. Okay. All right. All right. Let's do a little more challenging one.
I didn't even get the first one right.
It's not that much challenging. If you look at a problem and you see that they have a common factor, scroll up.
What are we listening to?
If
A
you
good
look
song.
at a problem and they have a common factor, you need to simplify before you do your 2 steps. So when I look at this, I have 12 plus 2x. Is there a common factor between my 3 terms?
Yes.
Yes. What is their common factor?
12.
2.
Oh, shoot.
Their common factor is 2. Their common multiple is 12. So their common multiple is 12, but their common factor is 2. And that's why it's a common factor, because I can divide each one of those numbers by 2. So before I do anything, I'm going to divide each one by 2. So when I divide each one by 2, it's going to leave me with
6 over 6 plus x.
So I'm left with 6 over 6 plus x. Now, is there anything else they have in common? No. So then I just go through my steps. So now, you're going to go through your steps.
2, 6,
What period is it?
7.
Yeah, for me.
I don't know
Are you
why for a
recording?
second I thought it was 8th period. I was like, oh my gosh, the day's almost over. It's not. Okay, no one cares. Mine isn't.
So it's gonna be -6, right? Yeah. So
So you gonna do nothing with the 6 on front?
Nope. It's all about your
it's gonna be
denominator.
-infinity, comma -6, u, and then it's gonna be -6, comma.
Perfect, yo. You got it. All right.
So
So,
the negative don't matter
what negative?
on the 6.
It's a number. It's -6. So we have 6 plus, oh, well, we didn't have that. So we have 6 plus x does not equal 0. I move my 6. So I have x does not equal -6. That's my inequality. And my interval, u, -6, infinity.
So what was this paper for?
Oh, I'm about to show you. All right. So tomorrow, while we are in the handy dandy gym for 7th period, I'm going to give you your assignment to do.
Oh, yeah, I can see it, miss.
So I'm giving you permission to take out your phone.
I can see it.
I will go back in a second, sweetie. I heard you.
Oh,
Yeah.
boy.
I need you to take. You're not participating. Your pep rally is until 8th period, so you're gonna work.
Opposites.
Okay, then you have homework. So you can do it before the pep rally and not worry about it.
That's
So
easy.
here is your.
My camera's up.
It is easy.
Wait. So I got a question for 59.
Yes.
So it's gonna be t minus or add.
T doesn't equal what?
So it's gonna be -infinity t. The whole.
0.
Oh,
T is x.
thought 0 wasn't a real number.
Yes. All right. So odds are your assignment. Evens are extra credit. Got it?
Odds.
Odds are your assignment. Evens are extra credit. If you're on the remind, I also will be sending it via that way.
Oh my gosh.
I know. That's what you have also. So you can have a backup. And I'm like, I didn't get it, miss.
It's gonna be me.
So you either can get it done tonight or do it.
I'm really grateful. I like that.